first thing to talk about is a shortcut for dealing with similar figures and their proportions or ratios. And that is, if you have any similar figures, and so any two squares, because squares are similar to each other, any two circles, circles are similar to each other. In this case, the sphere, any spheres are similar to each other. The couple relationships hold true. Anytime you have similar figures, the ratio of their parts, any one-dimensional measure, is always the same. And the way that that's designated mathematically is m to n is the ratio of parts. So like if you had two spheres and their radii were in a ratio of 2 to 1, that means that every one-dimensional measurement that corresponds between those would have that exact same ratio. So diameters would be 2 to 1. The circumference around their widest point would be 2 to 1. Any one-dimensional measurement that you could possibly measure will have that same ratio. Well, once you move to a two-dimensional measurement like area, what's going to happen is that ratio will be kind of multiplied once for each dimension. So it's no longer going to be just m to n when you're measuring an area. It's going to be m to n in one direction or one dimension times another m to n in another direction. So it's going to be m squared to n squared. So if you were looking at two spheres that had a ratio of radii of 2 to 1, their areas are going to have a ratio of 2 squared to 1 squared, so 4 to 1. Okay? And then when you move to 3 dimensions, so like a measure like volume, you're going to take that measurement or that ratio m to n, and it's going to be multiplied again by each dimension. So a volume is 3-dimensional, so it's going to take that ratio and it's going to cube it. And so using this understanding, you can answer the first part very easily. So part A, it says if the Earth's radius is 5 times as great as the inner core, and that means that the ratio of their parts is 5 to 1. Therefore, what is the ratio of their volumes going to be? That ratio to the power of whatever its dimension is. So volume is a 3-dimensional measurement. So it's going to be 3 cubed to 1 cubed, or 125 to 1. And so that would be the way that you would find that first piece of information. All right, the second one is a little bit tougher and involves kind of a calculation to it. And that is if you wanted to find the ratio of the outer core to the volume of the inner core. Well, the outer core is made up of, kind of if you look at the way that it's set up, is so you're kind of looking at this piece in here where you have the inner part compared to the outer part. The inner part is a radius of r. This outer part, it shows, is 11/6 r. And so in order for you to find just the volume of that ring, that 3-dimensional band that's formed there, what you're going to have to do is actually take the volume of the whole thing and subtract the volume of that inner core. Okay, so if you look at the volume of the whole thing, so the whole sphere that's the inner and the outer core together is, as if we use the volume formula, we're looking at 4/3 pi r cubed minus 4/3 pi, it's a different r. So this is, I'll call this R1 and R2. And so you're looking at these two different measurements. Well, since, again, just to simplify my calculations, they both have a 4/3 pi in it. So we're looking at the radius of the entire thing cubed minus, here we take out the 4/3 pi, left with the radius of the second, the inner core, cubed. And so if we measure that, the inner core is just an r, so we can plug that in. That's this inside number, so r cubed. And then the outer core, this has this radius of r plus 11/6 r. Well, if we wanted to combine those into one, we'd put them into the same fraction. So 1 is equivalent to 6 over 6. So 6 over 6r plus 11 over 6r gives us 17 over 6r. Okay, so when we find this, the ratio of their pieces, it asks us what's the ratio of the volume of the Earth's outer core to the volume of the Earth's inner core. So here's the outer core, 4/3 pi times, and we can calculate this. So 17, oops, I'll do it here. 17 over 6 cubed. So we're looking at, in this case, 4913 over 216. And we're subtracting r cubed from that. So this is r cubed minus 1r cubed. And so if we subtract 1 from this number, so I'm just going to take that number and subtract 1 from it, I get 4/3 pi times 4697 over 216. And we're finding the ratio of that to the volume of the inner core. The inner core is just 4/3 pi r cubed. Again, r is this, the radius is this r value. Okay? And so when we look at these combined, we can cancel 4/3 cancel, pi cancels, r cubed cancels, and so that winds up being your ratio.